Welcome back to another programming video using Python. Today's topic is going to be on control flow, making decisions, and what you're looking at is our roadmap. Back to VS Code, and this is basically going to be our learning approach today. I've laid the basic explanation at the top. We're going to go through a first example and then do a revision on comparison operators, and then look again at the another example just to kind of keep things fresh in our mind at the end of the day. Now, this is how we go about controlling the flow. Remember, Python runs from top to bottom, and we want to control that flow. And the way to go about doing that is using if. Now, if can run on its own. That's just something I want to highlight there. So if you're putting an if, think of it as in real life. If you do this, then I will do that. And if you do not do this, then I will not do that. So the same logic on a day-to-day life is what we try to achieve using code. At the exception that this is a machine and we are human beings. So we're transferring that the best way we can think of that the computer can interpret and process things in a way that we want them to process things. And this is just a small scale of what computers can do today. And hence, like I said in the beginning, these videos are just scratching the surface. If you need something that is more in-depth, more detailed, I will highly recommend that you look for a course that goes into more details in terms of Python principles, syntaxes, and so on and so forth. Now, having said that, this is the fundamental statement that you need to start off. That's a if. So you can have a if all by itself, and that's fine. But what you cannot have all by themselves is elif. That you cannot have. But so you need to have an if. You can also not have an else all by itself. That won't work. And that just makes things very easy. So you're always going to have to start with an if. And you can have an else if. And you can also not have it. And so there's just that scenario where you need to kind of understand what is possible and what is not possible before even getting into condition checks and doing something or doing something else. So that's good to know from the start. Now, like I said, Python runs from top to bottom, and the condition that you put here determine what runs under that condition. In order for Python to not give you any error or anything on the screen, you need to create this. You notice there's some sort of indentation or space that moves whatever need to run one or two indentation inside. And you see the same is repeated here, the same is repeated here. That's just like general standard as to how you separate what need to run under which condition. Now, if one thing you need to remember is that if you've laid your conditions to be in this format where you have an if, you have an else if, meaning another if, but you're adding an elf el in front of it. If you lay this in this format, only one condition must be true in order for the flow to stop. So basically, Python running from 10 to 17, I'm referring to the line numbers. If the condition is true for line 11, then it will run at 12 and it will stop. It will not bother running anything past that unless there is another code logic that is not associated with these conditions that need to run, then Python will run. So that's how you're controlling the flow. So you can run, Python can run a second time and go like, oh, well, 13 is true. And then it's going to do something else and then skip this part and then run whatever is not associated with this if else block. So everything is chained. I think now you're starting to see the control flow that can be achieved when using the if else if, elif, and else. Now, another thing also to notice is that L is always going to run if none of the previous conditions are true or turn out to be true. So if the conditions are not met and the first condition is not met, another condition is not met, then else will run by default because else does not have a condition. So therefore it's a default. And it's a good way to handle mishaps or things that may happen in the logic, and you always want to return some sort of a positive response, then this would be a good thing to put in there. Now, you can also have a series of if statement without having the remaining. So you can have an if like that. You can copy and have another if. What that means is that Python is going to run through all those conditions. The asks use cases where you can have that. Python will run through all those conditions, check them out, and regardless of either, it's as long as they are not chained like this, if and else if, then it will not mind going through each one of them. So that's another way of doing that. There is room for those kind of scenario. You just need to be aware of them. So then you can have multiple elif. So an elif need to precede an if or itself. So you can have another elif, like I said. You can have another elif here, if you put it that way. But you cannot have an elif after else. So you need to remember that's not going to work. So you need to have an elif. That's why I say elif. Not the else is. If you see what I mean. So you can have another elif, and elif can precede another elif, and elif can precede an if only. So those are simple things that make life a bit simple when you know them. So then putting things together and putting conditions together, you're not going to find yourself in a situation where instead of building, you're breaking. All right, I hope that makes sense in terms of explanation. Now I'm going to run this example where we're checking the age, and basically with our input, which is a way we getting information from outside the computer, outside the machine, we're telling the machine, or we're passing a value input to the machine and asking the machine and Python behind the scene to do some processing based on the logic that we've established. Now, the program here, what it does, it takes the age, compare it to set values. There are scenarios where you find this being used maybe in platform that are require you to be an adult, or platform that require you to be at a certain age, whatever the case may be, then those will be practical, and you may, based on the condition, allow the user to do something else depending on their age, or maybe suggest something else that is within the age range that they fall under. Now, once we get the age, pass it into the variable is age, and then we use that variable because it's an int based on what we've done. Input always returns a string, so therefore we need to surround that with an integer. It could also be a float, depending on the use case. If you, as we're gonna see down the line, in terms of numbers, and then I use that value and I compare. That's a comparison operator. So it's greater than or equal to 18. So if the age is equal to 18 or it's greater than 18, that therefore return this value, which is exactly what we're going to see here. So I'm going to run this code and I'm going to pass the age of 21. And that's what you see on the screen. You are an adult, which is basically that. And Python doesn't bother going to the next elif or else, because this is what turns out to be true because of the condition that returns true here. Now you may be asking, but where is the true is? That's done behind the scene, that's done internally. There's a longer way of writing this, but this simplifies the whole logic. And that's the beauty about Python, because there's a whole lot that is being done behind the scene that it only presents you with a simple and easy way to go about comparing or looking at things or even testing things, which is what I like about Python. Now, that is evaluating to be true for the condition that we've passed 21. And if we want anything, we want the age to be a teenager, so it has to be greater than 12, but it shouldn't be greater than 18. So what can that be? We can pass in a 16 maybe. Let's see, pass 16. Obviously it gives you teenager because 16 is greater than 12, but it's not greater than 18. You see the logic? It's kind of like in real life, it's like you're thinking of it like, how can I put something that I do on a day-to-day in a code format, and then this arrangement kind of lay it in a way that it's easy to translate something from a day-to-day life into a Python code. And here we're covering 2 age ranges, and the code is able to but do some comparison and then return the result. And then if none of the age is between these ranges, so we're going to run the code again and just probably pass 5, the obvious value you get is this is a child because your age is 5. And you can see it goes on and on and on to depending on what you want. You can have a series of if, you can only have one if, and a series of else if, and only one else. And you can have nested value, meaning under an if condition, you can have another condition. Maybe you're checking for a specific range within the 12 and the 18 age gap. Maybe you're checking for something else that the user might be entering, or maybe you want to ask something very specific. Then you can have that set up here and then do the other nested evaluation and still return the value that you want to return. So really it's up to you in terms of how far you want to go in terms of learning this, but this is just basically the foundation. Now I'm going to move up to the comparison operator as a revision, and just to refresh our mind on what is possible in terms of using these control flow and if and else, if and else. You can use operator like equal to meaning you're taking a value is equal to another, is double equal sign. If you're using only one, you're actually talking about operators like this, which is going to be your variable. If you hover over it, it tells you it's a variable. Then you're using one equal sign. Double equal sign, we're talking about comparison and we're expecting to tell us if it's true or false. Hence what you see here, equal to. Not equal to, exclamation mark, and equal sign, greater than, and the V inverted, facing the open side facing to the left, and then the lesser than is a V, letter V inverted, and the open side facing to the right. So that's a greater or lesser than. And the greater or equal to, same thing, letter V inverted, open side facing to the left, and then the equal sign, greater or equal to. And then you have the same for less or equal to for the values. So these are the comparison operator, and that is what we've used to kind of run this code and control the flow and tell Python when to stop in a way and when to move on. Now, the last example I want to run through, this one proves to be a little bit pretty straightforward. In this case, we are basically getting a number, and this time around that's a float. In the previous example, I use an integer, and like I said, you can also set that to be a float. And then basically you enter a number, and you enter the number and you do comparison. You say, well, okay, cool. If the number is greater than 0, then it's going to be a positive number. There are use cases for this. And if the number is less than 0, then it's going to be a negative number. And if you pass a value of 0, anything in between, not anything in between, if you pass a value of 0, then it's going to give you a value of 0. That's basically what it is. So I'm going to run that and see, enter number. I'm going to start with -9. It tells me exactly it's a negative number. If I run that again and I put the 9 as a positive number, And if I run that again and I put a 0, what do we get? It's a 0 because it's neither the first condition nor is it the second condition. Therefore, the default condition is printed out. Now, this is more or less what we are talking about when we're talking about a control flow. It's basically deciding when Python runs and when it stops based on set conditions. And this could be mimicking a real life scenario where you have to do certain things on certain condition, or maybe if the weather is temperature is 5 degrees, if something is maybe red or blue, then do this, or if the age is less than 18, then block this part of the programming, or don't do that. There's a whole lot of use cases for this kind of control flow. This is just the basic. I hope you've learned something new, and until next time, keep well. Bye bye.